Now here we have to talk about common ion effect. It generally belongs to chemical equilibrium, but here we have to see one more time. Suppose we have a equilibrium, we have a compound A P, which is in equilibrium and forming or dissociating in its ionic form A plus and B minus, and we have another a salt AC which is dissolving in A plus and a C minus. So we know that it is a reversible condition. Okay, it is a reversible equilibrium, or we can say it is a reversible condition. It is a reversible condition. Now means the reaction can go backward and reaction can move forward according to the given conditions. So now when AC is forming A plus and C minus and AB is forming A plus and B minus, so this is a reversible condition. Now A plus and C minus are forming. Now we know that that this reaction will keep going on forward. Okay, now we know the K equilibrium is constant. Suppose K equilibrium is concentration of A plus concentration of B minus divided by concentration of AB. Now we know that if these all are happening in the same container, the container is same where all these reactions are happening. So so how much A plus we are getting, it doesn't matter. A plus is A plus, whether we are getting from this reversible condition, whether we are getting from this salt. Okay, now further, now we know that the concentration of A plus has increased. This concentration of A plus is increased because A plus was already in solution. So now we know QC, that QC, the new concentration term, when A plus is a little higher, let's say A plus plus some X is there and B minus divided by AB. So we know QC is greater than KC. Here QC is greater than KC. So then the reaction will move in reversible direction. So that is known as common ion effect. So when a strong electrolyte, AC, this is a strong electrolyte AC is added into a weak electrolyte AB. This is a weak electrolyte. AB. Then concentration of A plus increases in the solution and degree of ionization of weak electrolyte decreases. And degree of ionization of weak electrolyte decreases. Degree of ionization decreases, and degree of ionization decreases, and that is known as common ion effect. If both electrolyte AB and AC are weak, then the degree of both, if we take a condition when both AB and AC are weak electrolyte, then the both degree of ionization of both decreases. So now let's talk about the pH. Now pH of a strong acid again, but let's dilute it more. So now if we have given a condition, what is pH of 10 to the power minus 8 molar HCl? What is pH of 10 to the power minus 8 molar HCl? So in that case we know that it is a strong acid, but it is very dilute. It is 10 to the power minus 8. So we know that water is also there. Whenever we have a solution, water we generally take as a solvent. Okay, so it is H plus plus OH minus. It will be keeping on dissolving like this. So now we know HCl is also there. HCl is also dissolving in H plus and Cl minus. H plus and Cl minus. So now we know it is a strong acid. Initially it was 10 to the power minus 8 molar. So it is 10 to the power minus 8 molar. Now it will become 10 to the power minus 8 molar, and the Cl, and this will also be 10 to the power minus 8 molar. Now we know that at 25 degrees Celsius we have to take the temperature at temperature equals to 25 degrees Celsius. We know Kw is 10 to the power minus 14. Kw depends on temperature. Okay, it depends on temperature. It depends on temperature. When it depends on temperature, it goes in X. Okay, it forms X. Let's say it form equal amount of H plus and OH minus. So it is X and it is also X. Now we know that H plus is already present in the solution. So whether it is coming from H2O, whether it is coming from HCl, so 10 to the power minus 8. So then it also is equals to X. Okay. Now we know that Kw will be equals to concentration of H plus into concentration of OH minus. That will be equals to 10 to the power minus 14. That will be equals to 10 to the power minus 14 if we have kept the temperature 25 degrees Celsius. When that is given, we will consider temperature as room temperature. Now what is H plus? H plus is whether we take from HCl, whether we take from H2O, that must be same. So it is X in X plus 10 to the power minus 8. Now what is concentration of OH minus? It is again X. That should be equals to 10 to the power minus 14. So now if we solve this equation, now it will be equals to X square plus 10 to the power minus 8 X minus 10 to the power minus 14 is 0. So now here if we solve the X, if we solve for X, X equals to minus B. Minus B is 10 to the power minus 8 plus minus under root B square minus 4AC. B square is 10 to the power minus 16 minus 4. A is 1 and C is minus 10 to the power minus 14 divided it by 2. That is divided it by 2. So here we get the value of X. X comes out to be 9.5 into 10 to the power minus 8. 9.5 into 10 to the power minus 8. And we have already calculated what is the degree of ionization of H2O. Degree of ionization of H2O is X divided by 55.5 into 100. That is degree of ionization of H2O. Now we know what is the concentration of H plus here. Now we have got the value of X. Now what is the concentration of H plus here? The concentration of H plus here is X plus 10 to the power minus 8. The concentration of H plus is X plus 10 to the power minus 8. And X we have got the value of 9.5 into 10 to the power minus 8 plus 10 to the power minus 8. So now it is 10.5 into 10 to the power minus 8. Now here pH we got, pH equals to minus log 10.5 into 10 to the power minus 8. So it is pH comes out to be 8 minus log 10.5. So that comes out to be 6.98. pH comes out to be 6.98. Now that's how we will calculate the pH. Now if we have given a strong acid, now let's see again. If we have given a strong acid, now in a strong acid, let's say concentration in a strong acid, we don't need to know anything apart from concentration. So now concentration, let's say C. C is the concentration. Okay. Now there are three conditions we need to see. In case of strong acid, there are three conditions. Okay. When concentration is greater than equals to 10 to the power minus 6, and concentration is in between 10 to the power minus 9 to 10 to the power minus 9 to 10 to the power minus 6. And now here C is less than equals to 10 to the power minus 9. So now we know here H plus is, here H plus net is C. We have seen already in case of HCl it was 10 to the power minus 2, then pH was 2. Now when concentration varies from 10 to the power minus 9 to 10 to the power minus 6, then 10 to the power minus 6 to 10 to the power minus 9, then H plus net comes out to be C plus X, where X is H plus from water, H plus from water. Now further, if we have it is greater than C, then H plus net 10 to the power minus 7. So there are, in case of a strong acid, we have only three cases. When concentration is greater than 10 to the power minus 6, then H plus is net. When concentration varies from 10 to the power minus 6 to 10 to the power minus 9, then we will have to consider the water also, because water, the concentration of H plus varies approximately is 7. So 10 to the power minus 7. So when it is in the order, then we cannot neglect the water concentration. Okay, the concentration of H plus from water, that is 10 to the power minus 7. When it lies between that range, then we cannot neglect it. We have to calculate the X from that quadratic equation. Now when concentration goes below to 10 to the power minus 9, then we have to neglect that concentration, and we have to consider the water concentration H plus is, that is 10 to the power minus 7, because that will be very negligible with water. So then we have to neglect that. So that's how we will calculate the pH of a strong acid.